So when you're ready.
Can you see the screen right now?
Yeah, it's kind of half screen though. It's looks like a cell phone thing or a PDF.
Okay.
It's not filling the whole screen. You got 3.25 slides on there. So.
How about now?
There you go. That's good.
Okay. So hopefully I'll be able to work this good. Oh, did I click on?
Here, you had it before. There you go.
All right, great. So this is an interesting lecture because, you know, I've been learning this stuff, especially over the past 2 years, working with Dr. Halassa, understanding redox reactions, understanding cellular biology, but understanding it in a deeper, richer way. In fact, it's almost as if I didn't learn it. And I think as I've understood COVID more and the different mechanisms of action, the ACE2 receptor, understanding renin-angiotensin on a deeper level, understanding how it connects to the immune system, and then really understanding how, you know, cytokine storms or inflammation over a long period of time starts to lead to autoimmune disorder, but in fact, that also leads to cancer. Okay, and it's almost as if I didn't really know that. There's a sequence to this whole thing. A lot of this complicated language actually makes sense once you get the language down. You know, interleukin 6, I mean, it's kind of hard to tag that to anything. So let me see if I can get to the next screen here. Okay, so this is kind of like Journal Club, and I may have to switch to another slideshow after this in order to show the pictures. But I think the main thing is to know that you can also create the picture in your mind. And when you have the picture in your mind, well, you really actually do know it. And if you can add some flavor to it, that makes it even, makes it animated actually. Interleukin 6 and inflammation, autoimmunity, and cancer. Interleukin 6 involved both in immune responses and inflammation, hematopoiesis, bone metabolism, and embryonic development. Okay, now this is straight from this article from literally a year ago. So interleukin 6 is a big player. I think if there's one interleukin to really think about, it would be interleukin 6, because it seems to be connected to, it's the crossroads of all the major diseases. But it has different functions, and that's why it gets confusing, at least to me. It's involved with different things, good, bad, the good, the bad, the ugly, and they're not necessarily related to each other. Interleukin 6 plays roles in chronic inflammation, closely related to chronic inflammatory diseases, autoimmune diseases, and cancer, which is my point. And even in the cytokine storm of coronavirus disease 2019. Thanks to COVID, I think I understand this stuff better, unfortunately. Acute inflammation during the immune response and wound healing is a well-controlled response, whereas chronic inflammation and cytokine storm are uncontrolled inflammatory responses. Back to basics, it's this out of control thing that causes us to get into trouble. Otherwise, our inflammatory system and interleukin 6 is a well-oiled machine. Synergistic interactions between NF-kappa beta and STAT3 induce the hopefully I won't mess up my screen here if I bring this down, hyperactivation of NF-kappa beta followed by the production of various inflammatory cytokines. So here's the big aha. there's a synergistic interaction between NF-kappa beta and STAT3. And if you're having trouble, if you still don't really know what they're involved with, maybe you do, maybe you don't. These are pathways within the cytoplasm of the cell that are normally inactive. They're not doing anything. But if they both become active, well, in other words, one can cause a sequence of events that can enhance the other. And what they're involved with is the transcription of certain genes in the nucleus, causing the production of certain chemokines that attract the immune system, or in the case of STAT3, it's actually involved with cellular division. Okay, so we have one, NF-kappa beta really is the immune part of the process of transcribing within the cell and calling other immune cells to the area. And the other is STAT3, which is involved with cellular division. Well, you understand what I'm saying, what I might be getting at is cellular division needs to be a well-oiled machine, because if cellular division gets out of hand, well, then we've got the possibility of cancer. STAT3, and I'm going to try to rattle this off the top of my head, what these mean. Signal transducer and transcription. Okay. And if you really look at what a transducer is, in the literal form, it's the transformation of one energy form into another. So like a stereo takes electricity and transforms it into sound. Well, imagine that the cell is being activated, it's an energetic process, and then it changes that energy, who knows, maybe into a sound energy, and that's what modulates the genes. Just a way to think about it. Because interleukin-6 is an NF-kappa beta target, simultaneous activation of NF-kappa beta and STAT3 in non-immune cells triggers a positive feedback loop of NF-kappa beta activation by the interleukin-6 STAT3 axis. So because interleukin-6 is an NF-kappa beta target, well, really what's happening is NF-kappa beta triggers the chemokines, the nucleus of the cell, if it's activated, to produce chemokines which attract monocytes, which come to the area of injury, for which they can be triggered to release interleukin-6 based on the communication signal and what's going on. And when the T helper cells come to help, they take on that signal, and the T cells these are T helper cells, turn or differentiate into Th17 cells. And it's really the Th17 release and the interleukin-6 that gets released. Well, that activates and triggers in a loop the NF-kappa beta, because the interleukin-6 and the interleukin-17 can activate the STAT, and when STAT gets activated, that enhances NF-kappa beta that's already activated. Okay, so I had to go through a lot of this stuff in my head. It's not easy. This positive feedback loop is called the interleukin-6 amplifier, and is a key player in the local initiation model, which states that local initiators such as senescence, obesity, stressors, infection, injury, and smoking trigger diseases by promoting interactions between non-immune cells and immune cells. Okay, so you see that you have non-immune cells, which are triggered by senescence, obesity, stressors, infection, injury, smoking, viruses, okay? And that those non-immune cells then call or communicate with the immune cells. So it's all about this non-immune cell, immune cell interaction, and the positive feedback loop is like the combination. You have too many of these things going on, and this amplification process happens with interleukin 6 being the main player. Interleukin 6 begets interleukin 6. Macrophages produce the interleukin 6. The T cells differentiate into Th17, and those produce interleukin 6. And pretty soon you've got a wildfire brewing. Interleukin 6 amplification is activated by a variety of local initiators, demonstrating that the interleukin 6 STAT3 axis is a critical target for treating diseases. We got to focus on something. It's going to be the place to do this. And of course, with COVID, they were doing in extreme cases in the hospital, giving a medication to block interleukin 6 directly to try to block the cytokine storm. So we are absolutely talking in the right direction here. Inflammation is a complex process in which a variety of cells, including B lymphocytes, T lymphocytes, myeloid cells, epithelial cells, fibroblasts, endothelial cells, muscle cells, adipocytes, interact with each other through membrane-associated molecules. Matrix metalloproteases and soluble factors such as cytokines, chemokines, and growth factors. So yeah, I mean, there's a lot going on. You know, when they think of matrix metalloproteases, think about something that is breaking something down, maybe perhaps breaking down cell adhesion molecules, allowing, say, in the case of endothelial cells and the vasculature, allowing leukocytes to migrate into the blood vessel intima. Okay, so some of this stuff is part of our old knowledge, and it does all fit together. Think of fibroblasts as, in the context of cancer, suddenly become transformed into cells that produce a matrix that protect the cancer. Okay, and that's why cancer, one reason why cancer is so hard to treat. T cells, B cells, if T cells are differentiated a certain direction, well, that's going to lead to this, amplification process. Interleukin 6 was discovered in 1986, is a pleiotropic cytokine involved not only in immune responses, but also in inflammation and hematopoiesis, bone metabolism, embryonic development, and fundamental process. I just say this again because pleiotropic cytokine, it just means that they are involved with so many processes that are seemingly unrelated, and that this will make sense even more when you realize that interleukin 6 then can also affect a lot of other things if it's going in the wrong direction, seemingly unrelated things. Interleukin 6, this is the repeat. Studies in the 1980s also showed that interleukin 6 is produced by cardiac myxoma cells and Castleman's germinal center cells, and is present at high amounts in the synovial fluid of rheumatoid arthritis patients. Hopefully can you hear me okay?
Yeah, we're good.
Maybe not.
Yeah, we're good.
Oh, good. Okay. I just put on my earbuds. Thank you. Okay. So You know, and by the way, after I did this, worked on this presentation with my mother. She's a retired DO. And, what we realized is that this is, it was a Japanese article, and that the translation to English, believe it or not, may have made it extra complicated because things are kind of all over the place. And, we had to kind of tie it together. And so, Castleman's Germinal Center, cardiac myxoma, again, this is just saying that, look, these are different. We're talking about tumors, we're talking about rheumatoid arthritis, but interleukin 6 is the common denominator. It's found in high amounts in these situations. Castleman's Germinal Center, I believe, is it's a lymphadenopathy, or it's a lymphatic tumor of a certain kind. And of course, we know cardiac myxoma being a tumor of the heart muscle. The original hypothesis has since been updated and is here called the local initiation model, which emphasizes the importance of local initiators such as infection, injury, and stress in the promotion of interactions between non-immune cells and immune cells in disease. Again, that's kind of what we keep saying. If you get enough of these stressors, then this amplification, okay, you get COVID, and you have Epstein-Barr, you have obesity, you have diabetes, or you have chemical exposure, you've got 5G, you've got a stressful life, your inflation, wildfires. So, furthermore, tissue property dependent events, microbleeding, neurostimulation, cellular senescence, and oncogenic mutation in preneoplastic cells have been shown to trigger these interactions. I mean, you have vaccines, you've got another variant of a virus, and with each hit, what if it's like you're working your way, the body's heating up with each hit, especially considering a certain virus that we know polarizes specifically to Th17. And Th17 is the common denominator of autoimmune diseases. So if you already have, psoriasis or ulcerative colitis, you already have that Th17 dominance. And if you don't know the different polarities in T cells, you've got Th1, Th2. You've got Th17, T regulatory cell. Everything's in the yin yang. T regulatory cells calm the fire down. Th17 really is involved with mucous membrane stimulation, ultimately to fight off bacteria in a sense. I mean, that's really its primary function. That's why it's so destructive. And then again, if you think about COVID, it pushes all the buttons to make the body think it's fighting a bacteria. Then you've got the abnormal, that's why you have the necrosis of the lungs. You've got neutrophils getting stuck into the traps within the, the alveolar microcirculation, with the other changes that are happening to those cells. And so, why would you have a ground glass appearance? Well, because the body thinks it's fighting a bacteria, and neutrophils are destructive. They cause necrosis. Furthermore, tissue property dependent events, microbleeding, neurostimulation, cellular senescence, oncogenic mutations, and preneoplastic cells have been shown to trigger these interactions. Okay, so many different things that could play a part. Interleukin 6 is also a key factor in inflammation, autoimmunity, and cancer, with its effect mainly exerted through the interleukin 6 signal transducer and activator of transcription 3. We talked about it, signal transducer. This is an amp. I see it as almost like a bass speaker with a loud boom. It gets activated, and that turns on certain genes. I mean, it requires a spark for everything, especially cellular division. but it requires a very fine-tuned frequency. You don't want, the wrong frequency, and then that's where things start to go wrong. The interleukin-6 amplifier is an amplification mechanism for the production of interleukin-6 and a variety of other cytokines and chemokines through a synergic interaction between STAT3 and nuclear factor kappa beta, B, for B cell. That kind of makes sense too. Okay, so you have interleukin-6 that activates the STAT3, and then that sonic boom triggers the NF kappa beta, because NF kappa beta, I guess my understanding, it's really oxidative stress that turns it on. And of course, what we've learned from the nitromedicine group is that when COVID activates the sequence of events that causes polarization of angiotensin 2 not converting to angiotensin 1-7, when that overabundance of angiotensin 2 hits the angiotensin type 1 receptor, that triggers an enormous, that shouldn't be happening. That triggers an enormous amount of oxidative stress, the beginning of the cytokine storm, which activates the NF kappa beta. And then that leads to the production of chemokines and that call those macrophages to the area. And then those macrophages lead to the changes in the T cells, and then the neutrophils that come in and cause, all the destruction because they think they're fighting something else. Interleukin-6 expression, interleukin-6 receptor, and its mode and signaling. The interleukin-6 receptor is composed of an interleukin-6 binding receptor molecule, interleukin-6 receptor alpha. Okay, so this is where things get confusing again. Okay, yeah, we've got a receptor here, but it's a signal transducer called GP130, which really is just a glycoprotein. And I wish I would have had I'll try and get the pictures, but I think you can picture in the mind. Just picture two arms as a receptor on a cell, and then a head in the middle. And the head is the glycoprotein 130. And interleukin-6 requires that in order to trigger the events that are happening. If there are cells that have glycoprotein 130, just the head by itself, but interleukin-6 by itself will not do anything. It needs the lock and key. Interleukin-6 activity. The expression of both interleukin-6 receptor alpha and GP130 on the cell surface is required, which limits the number of target cells on which IL-6 acts to lymphocytes, myeloid cells, and hepatocytes. So like I said before, you need the arms and the head. However, interleukin-6 complex with the soluble form of interleukin-6 receptor alpha. Okay, now this is different. This is the soluble form of interleukin-6 receptor alpha. In other words, that receptor can be cleaved. It can be cleaved off of the cell in a soluble form, float around in the circulation, and can attach to interleukin-6. And when that happens, well, then you already have the interleukin-6 connected to the receptor. Then all it needs is the GP130 that's sitting on all the other cells. And then you start triggering things in other cells that don't need to be triggered. And then you start having more than one autoimmune disorder. Think about that. Or you have a systemic effect. I mean, think about COVID long haulers with all the different symptoms that don't necessarily, they're not the same for each person, but they're a variety. And imagine that this overabundance of interleukin 6, and it being connected to its receptor, floating downstream, and for example, attaching to the blood-brain barrier endothelial cells that only express the GP130. And then you have inflammation, or the beginnings of neuroinflammation and letting of things into the brain that shouldn't be let in. Perhaps COVID that has hijacked a neutrophil. And then the neutrophil actually brings COVID inside. I mean, it's a really remarkable virus. I mean, it's amazing that nature randomly produces these amazing, perfectly constructed viruses to do all these things to our body, and in a beautifully orchestrated way. Through this mechanism, a cytokine requires a novel function, namely cytokine soluble receptor complex function, to act as a novel cytokine on target cells. Okay, so just like what we said, it just requires a target cell with the right combination of receptor. This mode of interleukin 6 action is now called the trans signaling mode. Trans signaling mode. So it's I guess what would be the best way to describe it? It's transitioning into other places. It's a transition to affecting all these different other organs. While the original membrane type is called the classic mode. So if you have a well-orchestrated, regular acute inflammatory response, you're going to get a classic interleukin 6 binding of receptors, and the right cells will come in and do its job, and then it will heal itself up, and then you get better. Trans signaling is the problem. Trans signaling mode expands the range of cells that respond to interleukin 6 because GP130 is expressed in a wide range of cells, including endothelial cells and fibroblasts, explaining one of the mechanisms by which interleukin 6 acts on a wide range of cells and tissues to exert a pleiotropic function. A good one is, why would somebody with psoriatic arthritis also have osteopenia? Right? Doesn't seem like it makes sense. Well, if you have interleukin 6 amplification and it has a wide variety of functions seemingly unrelated, well, then you start up a inflammatory process of the bone, and then you have osteoclast overactivity breaking down bone, forming osteopenia. And I don't think that just taking a calcium supplement is going to help that issue. One example has interleukin 6 together with soluble interleukin 6 receptor alpha acting on endothelial cells that express only GP130 to induce STAT3 activation, chemokine expression, and the augmentation of ICAM1, thus contributing to local inflammation by activating leukocyte recruitment. So you've got this ICAM, that is a metalloprotease. Okay, now don't quote me on this one, but I think that's involved with the breaking down of the adhesion molecules that allows the leukocytes to infiltrate the area. And it's augmented because the interleukin 6, STAT3 triggering NF-kappa beta collectively trigger that. And so ICAM, you can see it, adhesion molecule, AM, adhesion molecule. Some of the weird scientific terms that I've come across. I've tried to figure out what it means, how do I drill it into my head without it being rote memory. And sometimes they actually make sense what they mean. Sometimes I have to write it down. Sometimes I forget, like with ICAM. And there may be interstitial cellular adhesion molecule, but that tells you what's going on. If that's augmented and then it's breaking down, everything is cause and effect. This causes that. Some of the abbreviations actually have a lot of Latin and Greek roots. And ironically, they actually are very vivid. If you really understand the Greek roots, they tell a story and they're related to mythology, and that's when it gets really cool. In addition, interleukin 6 and soluble interleukin 6 receptor alpha induce that's the soluble form. They bind and they can affect all the other wrong cells, induce a transition between the early predominantly neutrophilic stage of an infection and the more sustained mononuclear cell influx, contributing to the switch from acute to chronic inflammation. Okay, so this transition starts the process of it being something that would just go away, done deal, to this chronic process, sustained inflammation that leads to eventually autoimmune and to cancer. Okay, we didn't really learn it like that in medical school, and that's okay. Because actually now it makes a lot more sense. The body just randomly going, oh, I don't know if I should hurt you or not. It's not that. You've there's too many stressors overactivating a well-oiled machine, and now it's gone out of control. Further, they act on fibroblasts and endothelial cells to recruit T helper Th17 cells, leading to a rheumatoid arthritis-like joint disease and experimental autoimmune encephalomyelitis. Well, that reminds me of COVID vaccines. If somebody gets like a like red swollen joints out of nowhere for no reason, or they start developing, signs of Guillain-Barré or multiple sclerosis, or just having brain fog. Okay, so COVID really triggers this amplification. I mean, it's just causing all of these things. It's like speeding up the process. I mean, yeah, it's almost like if you wanted to speed up what would eventually happen to mankind, that's a slow process. Give them bad food and then put them on medications, and then it's like the slower way. If you wanted to speed it up, why don't you just put a virus that just does the amplification, hits all those receptors, the brain, the everything, and you speed up the process of getting very sick. Soluble interleukin 6 receptor alpha is generated mainly by proteolysis by Adam17 and a minor extent by alternative splicing in humans. So it's this atom, and I got to stretch my brain here to see if I remember exactly what it means. It's a bit okay. So disintegrin, that's what the D stands for, disintegrin, disintegrate. So if you disintegrate the receptor, you're cleaving it off, and then it floats around in the bloodstream and binds to interleukin 6, which allows it to hit other cells in the body. Notably, soluble interleukin 6 receptor alpha is increased in several diseases, indicating that trans signaling plays important roles in the progression of inflammation in many diseases, including severe COVID-19. I almost forgot that they even said this in this article. I was kind of putting it all together in my head. Interleukin-6 activates Janus kinase family tyrosine kinases through GP130, leading to the activation of STAT family transcription factors, mainly STAT3, as well as SARC homology region 2 domain containing phosphatases, phosphatase 2, GRB2 associated binding protein, GAB, extracellular signal regulated kinase, ERK, and mitogen activated protein kinase, MAPK signaling pathways. Now, I probably put that more in there because I wanted to make a driving point. Janus kinase, STAT, and all these pathways are involved in mitosis, apoptosis, and think about it this way. I thought about this with the mitochondria, you know, how there's an electron transport chain and the electrons being, you know, taken by something that has a more affinity and then something tears it off of that. Well, you can imagine like there's that kind of chain process happening in the cytoplasm activated by the receptor, and that its phosphatase is what's being handed off and torn. It's not electrons. That's the more quantum level of the cell. Phosphorus is the currency, and different molecules have different affinity for it, and so you have this phosphorylation process being handed off. Well, actually, it makes sense. It's strange, but Janus kinase. Janus is Greek for the two-headed god, G-O-D. And the face is face out. That's strange. So it's like a god that has a face going in this direction and a face going in that direction. And they refer to him in mythology as the god of, I'm using my words now, beginnings. And then when you think about it, Janus also is the root for January, which is the beginning of a new year. That ultimately leads to, you know, I guess, you know, there's spring and summer, and you know, there's cycles. Well, cells have cycles too. That gets activated. When it's activated right, there's these series of events that happen, you know, the passing of the phosphorus. Phospho in Greek means light. And it actually, if you look at pictures, if you Google pictures of phospho, maybe Greek, I don't remember what I came up with, but you see it's really referring to the goddess of Venus holding like a torch. Not sure if that's the right word, but think of the Statue of Liberty. That's actually what that refers to. And then if you think of the Greek Olympics, you know, think of how they, and you know, as the opening of the Olympics, how they pass the torch, you know, the running, and they pass the torch to the next person, eventually to the last person that runs into the stadium and up to the main part. It's almost like he's going into the nucleus, and then things where the real game happens. How to remember all this other stuff? SARC that literally means sarcoma. So already, you know, that's a tumor pathway, or you know, associated, connected to sarcoma. Mitogen activated protein kinase. I mean, mitogen, mitosis, cellular division. And just know that these other pathways are, I could try to get in there and translate them, but you know, you can also, and some of them just don't relate to anything. It's just whatever it, you know, the scientists wanted it to be. Like tyrosine comes from tyro, which means cheese, because they discovered it in cheese in the casein. I mean, you know, so not cool like Janus and phosphorus and all that stuff. Involvement of interleukin-6 in chronic inflammation, autoimmune diseases, and cancer. Environmental factors such as infection, stress, obesity, aging, smoking, each of which can induce chronic inflammation, could be a major cause of oncogenesis. Just after the molecular cloning of interleukin-6, cardiac myxoma cells were found to produce interleukin-6. Patients with cardiac myxoma and a variety of autoimmune disease symptoms, including hypergammaglobulinemia, autoantibodies, and increased acute phase proteins. Okay, so, already you can see that, there could also be antibodies going on there. But, I think at the end of the day, most of these autoimmune diseases become Th1 dominant, Th17, and so it just depends on. Th2 would be the part of the polarity that where the B cells are creating the antibodies. But you could have one more dominant than the other, and I'm just saying that just to say it. Just after molecular cloning of interleukin-6, the other thing I want to say is that. And I don't know if I put it in the slide, but they propose that 85 to 95% of cancers are actually environmentally related, as opposed to, oh, you just have you're genetically susceptible, which would be 5% of the time. Well, that says something about how important the environment and what we can do. I mean, even my place, it's like now I've got all these different air purifiers. I found out I had mold in my heater, and these things. The way I see it is they add up. Okay, so now you throw COVID into the mix, and suddenly if you've got if you're breathing a lot of particulate matter outside, if you're in the city, if you're breathing in mycotoxins, if you're drinking toxic water, I mean, it's not purified, or you have chemicals, and they start to add up, and then if you get an amplification process, that's when something's going wrong. If you feel really bad, you got to do something about it. You're going to have to eliminate all the things that could be adding to the stressors. Otherwise, you're heading down a bad road. And actually, I was working with another mentor who said, at some point, the cytotoxic T cells start to burn out. And then that's what's actually preventing or keeping cancer at bay and getting rid of viruses and stuff like that. And once that peters out, he said, very quickly, bad things happen. These symptoms disappear after surgical resection of the tumor, suggesting the intimate relationship between cardiac myxoma and autoimmune symptoms. Genome-wide association studies, meta-analyses, exome analysis, and single nucleotide polymorphism mapping have associated interleukin-6 receptor, and GP130 with inflammatory diseases such as RA and coronary artery disease. It was also reported that interleukin-6 receptor is associated with asthma and atopic dermatitis. Like all of our problems. Crosstalk between non-immune cells and immune cells through interleukin-6 amplification. Okay, so hopefully you're hanging with me. Try to keep this interesting. Just get the picture in your head. You got it. Furthermore, interleukin-6 and interleukin-17 or TNF-alpha synergistically enhance the production of various pro-inflammatory mediators, including interleukin-6, from non-immune cells in a manner dependent on STAT3 and NF-kappa beta. Now, this is where I think the English gets, I think I was getting confused. I'm like, okay, what's triggering what?
Imagine that interleukin 17, I still think it's the damaged cell that calls the macrophages. The macrophages produce the interleukin 6 and the TNF alpha, polarizes T cells to the helper cells to interleukin Th17 cells, which produce interleukin 17. Well, interleukin 17 indirectly triggers, it's calling the neutrophils, and then that neutrophilic destruction causes more oxidative stress within the damaged cells, which if you've got interleukin 6 at the same time is also activating STAT3. STAT3 enhances NF-kappa beta, which causes more of the immune cells to come around. The produced interleukin 6 further induces Th17 differentiation through STAT3 in the presence of TGF beta, interleukin 1, interleukin 23, all of which are rich in inflammatory lesions and tumor microenvironments. Okay, so maybe STAT3 is also in the T cells because that's causing a differentiation. And these other cytokines, TGF beta, interleukin 1, interleukin, these are common in, abundant in inflammatory lesions and tumor microenvironments. So those are also, accelerating this process and this polarization of Th17, which is producing more interleukin 6, which is causing triggering STAT3 in the damaged cell or in the I always say milieu. Some people say milieu, almost like it's French. No? Anyways, therefore, there is an in vivo positive feedback amplification loop of interleukin 6 production via Th17 differentiation and their interaction with non-immune cells such as fibroblasts. So now the fibroblasts are being affected by this loop, and suddenly the fibroblasts are playing for the cancer team. The interleukin 6 amplification could be exerted by several mechanisms. Or think about this, you get really bad injury and you start developing a lot of scar tissue. And TGF beta, that's also a scar producing, so you have the joints that get hypertrophied, like finger joints, and you get the big knuckles and metacarpal, okay? Well, it's laying down scar tissue. Well, those are fibroblasts, what they're producing. The interleukin 6 amplification could be exerted by several mechanisms. We know that. For example, STAT3 prolongs NF-kappa beta nuclear retention through the acetyltransferase P300 mediated something acetylation, REIA acetylation, thereby interfering with NF-kappa beta nuclear export in both cancer cells and tumor-associated hematopoietic cells. Okay, so there's this pathway. This is just showing exactly how STAT3 prolongs NF-kappa beta retention, or keeps it active and calling those immune cells. Okay, NF-kappa beta is the immune call celler. That's its job, calling those immune cells, and STAT3 is the cellular division differentiation. Not a good thing to have it overactive. And this is the specific mechanism, acetylation, whatever that means to you, acetyltransferase. I haven't really dug in deep into that, but just know that one activates the other. As described above, the interleukin 6 amplification is a mechanism by which the regional production of a variety of cytokines and growth factors is augmented through the interaction between NF-kappa beta and STAT3, both of which are activated not only in inflammatory lesions, but also tumor microenvironments and neoplastic tumor cells. So you can imagine that these very inflamed cells in this bad milieu that's overactivated, eventually producing tumorous cells. And then those tumorous cells also have the same amplification process that makes it even worse, perhaps causes it to metastasize. Furthermore, NF-kappa beta, STAT3 play crucial roles in cancer development and progression. Thus, the interleukin-6 amplification plays a crucial role in not only in chronic inflammatory and autoimmune diseases, but also cancer. The interleukin-6 amplification is activated not only in non-immune cells such as fibroblasts and endothelial cells, but also in grafted organs and tumor cells, acts as a linker between these cells and immune cells by attracting immune cells through the production of a variety of chemokines. And we know that now. Chemokines, that's what it is. It's the attracting, with all these different interleukin this and interleukin, to me, that's communication between leukocytes, interleukin, interleukocyte, chemokines. It's attracting, almost like perfume or something. The interleukin-6 amplification, which is activated not only in non-immune cells such as fibroblasts and endothelial cells, but also in grafted organ. Oh, okay, said that already. Local initiation model. In 1964, Boyden pointed out the importance of local initiators such as injury or infections as triggers of inflammation, followed by the destruction of target tissue. So even he says in 1964, it's these local initiators. Decades later, Wilkin proposed the primary lesion theory, in which the primary lesion triggers autoimmunity rather than the popular view, which held the primary cause of autoimmunity was the breakdown of self-tolerance. So I guess it's sort of the same thing. So I guess there was a popular view. I mean, he's saying the same thing. It's the popular view is that, oh, okay, you just can't tolerate yourself. It sounds kind of ridiculous now. Patients with rheumatoid arthritis show a variety of symptoms, including polyclonal plasmacytosis, accompanied by the production of rheumatoid factor, enhanced bone resorption, and increases in the amount of acute phase proteins, agalactosyl, IgG, and platelet numbers. Well, it just says rheumatoid arthritis, they show a variety of symptoms. I mean, look, you've got plasmacytosis, you've got, production of more plasma cells, rheumatoid factor, which can be measured, enhanced bone resorption. Okay, we talked about that before, increased osteoclast activity. And that you can see how that would start to break down the joint. And increases in the amount of acute phase proteins and platelet numbers. And, we kind of know that association with COVID, increasing, activating platelets and, at least systemically. And you start to see that, wait a minute, there's a connection here between these processes. They're not all separate. None of these phenotypes at first glance appears to be related to each other, suggesting that complex factors are involved with rheumatoid arthritis. Yes, we know that now. The local initiation model is similar to the primary lesion theory proposed by Wilkin, but the former clearly shows that the key role of transcription factors, NF-kappa beta and STAT3, which can simultaneously induce multiple actions and be activated by a variety of local initiators. They are the common thread. persistent local initiation activity, such as chronic infections with or without genetic factors, leads to chronic activation of interleukin 6 amplification. This effect induces the manifestation of inflammatory diseases and autoimmune diseases. Now we know. A variety of stressors such as pain, light, and gravity are sensed by a sensory sympathetic neural network. Okay, again, you know, it's like patchwork, but when I look this stuff up, I'm like, oh, wait a minute. Okay, well, it's gravity. So now I'm imagining back pain that becomes chronic, and pain. Well, you know what they're saying is this, and that the sympathetic nervous system. You imagine somebody with chronic pain, and then they've got, you know, their parasympathetic. I always think in terms of polarities. Okay, you got sympathetic, parasympathetic, as our autonomic nervous system is polarized towards sympathetic, and that sympathetic neural network can trigger and enhance the amplification and allow inflammatory cells into the spinal cord. Neuroinflammation is associated with the invasion of various immune cells in the central nervous system, followed by the dysregulation of homeostasis in the brain and spinal cord. Okay, so dysregulation of homeostasis. It's all about this homeostasis and dysregulation, that suddenly things are being let in. Neuroinflammation is, imagine neuroinflammation causes the polarization towards sympathetic, and that can affect the spinal cord. However, the CNS is protected by the blood-brain barrier, which tightly limits the traffic of substances and immune cells from the blood. Yes, but if you have amplification, the blood-brain barrier starts being activated and the adhesion molecules broken down, which is allowing bad things to get in. In an adaptive transfer model of autoimmune encephalitis using myelin-specific autoreactive CD4 T cells, it was found that the initial invasion of these cells is determined by specific neural activation through the sensory sympathetic pathway stimulated by gravity. Now, back to the lower back, that pathway and gravity is actually, it's a muscle, and I apologize, I think it's the soleus muscle, but the tightness of that muscle, which connects to the lumbar spine, triggers a sensory sympathetic pathway. If the gravity is coming from the muscle pulling down on the vertebra. Okay, that's what's going on, and causing CD4 cells to invade the dorsal horn of the spinal cord. This neural pathway, which is now called the gateway reflex, activates the interleukin 6 amplification through beta adrenergic receptors in the dorsal vessels of the 5th lumbar cord, allowing for autoreactive T cell accumulation and disease onset. Well, now you've got an chronic inflammatory process started in the spinal cord, just from a tight muscles in the legs, and maybe there's some other initiators, but that now you're getting, you know, chronic, almost complex pain syndrome, and that could also, you can imagine that that could affect, you know, that can move up and down, and that can affect neural connections over time, perhaps to the gut, and perhaps you might have the triggering of Crohn's. Now that's my take, but that's my speculation. Further pain sensation induces a relapse of autoimmune encephalitis by activating the interleukin 6 amplification through another sensory sympathetic neural network. And just know that, you know, it still comes down to interleukin 6 and this activation of STAT3, whether it's happening in the spinal cord, whether it's happening in the endothelial cells that normally protect, you know, you imagine that there's a blood-brain barrier to the spinal cord, and you know, this calling of Th17 cells, and they're releasing interleukin 6, and maybe there's soluble interleukin 6 that is binding to those GP130 receptors, that the head by itself, because it's got the arms, and then suddenly these Th17 cells are getting into the dorsal horn of the spinal cord, and they're calling the neutrophils, who think that they're fighting a bacteria, and then you've got damage. Age-related changes in senescent cells also act as local initiators. Senescent fibroblasts secrete high levels of several metalloproteases, endothelial growth factor, and inflammatory cytokines resembling fibroblasts undergoing a wound response or associations with cancer. So now, if we get older, we've got these senescent cells that are these inflammatory factories, only adding to the abundance of initiators that are collecting and causing amplification. Obesity causes chronic low-grade inflammation and is closely related with chronic inflammation diseases such as cardiovascular diseases, type 2 diabetes, and some cancers such as breast, liver, and colon cancers. So yeah, okay, obesity, and you've got all of these inflammatory cytokines coming from the fat cells. I believe they actually do release, I mean, they attract, a lot of fat attracts immune cells. And then if you have, then you imagine that if it's enough, then those interleukin 6 cytokines can be attached to those receptors and start to seed inflammatory processes in other parts of the body that are already probably starting to get inflamed. And then you've got breast, liver, and colon cancers. The enlargement of adipose tissue and obesity induces mechanical stress. It's the reticulum, that the part of the inside of the cell, endothelium reticulum. Don't quote me on that. Stress and hypoxia in adipocytes, resulting in the release of free fatty acids and inflammatory cytokines such as, like I said, interleukin 6 and TNF alpha and chemokines. TNF alpha sort of being part of this amplification process of interleukin 6, suggesting activation of the interleukin 6 amplification. Pre-neoplastic cells or cancer cells by themselves act as local initiators, such as senescent cells do. Okay, I think we're getting close to the end, close to landing the plane here. Either or both the STAT3 and NF-kappa beta are activated in a variety of tumors, including lung, breast, and pancreatic and prostate cancers. So, you know, after I read this, I said, that's it. I'm doing intermittent fasting. We've got all these other stressors going on. You know, then we got COVID in our body in reservoirs, or they say it's debatable, but I've come across enough data. It can stay in our central nervous system. I don't want to give it any more fuel. All of the above results are in line with cancer cells activating the interleukin 6 amplification through the direct or indirect activation of NF-kappa beta and STAT3, likely resulting in the recruitment of Th17 cells and or myeloid cells to further enhance interleukin 6 amplification. My mentor, Dr. Halassa, I mean, it's been all about Th17 polarization with our group for the past 2 years. I had never heard of it. In fact, you know, I realized that we were actually at the forefront, literally, of recognizing and understanding Th17 as part of this polarization process But then when I went through all the data from like 2013, you could see that every autoimmune disease that I looked up on PubMed, sure enough, Th17 dominant. Infection is a local initiator that triggers and maintains inflammation, leading to chronic inflammatory diseases and cancer. TLR stimulation also induces interleukin-6 production and other pro-inflammatory cytokines through NF-kappa beta, leading to activation of the interleukin-6 amplification. Therefore, infection is one trigger of the interleukin-6 amplification. So, you know, it's the way I understand it is toll-like receptors, TLR. It's almost like a toll booth receptor, or in other words, it's a tongue that tastes and starts to recognize that there's infection, and that leads to the interleukin-6 amplification through, it's got its own NF-kappa beta, you know, leading to the series of events that polarizes the Th17 cells, which produce more interleukin-6, and then they go through their own amplification process. Therefore, infection is one trigger, and again, you can see that with COVID, because COVID was also triggering macrophages, from my understanding, directly, because they also do have ACE2 receptors, I believe, or it was the toll-like receptors that, you know, somehow were tricked into thinking it was a bacteria. Now, again, I'm still learning in refining, but COVID was overactivating macrophages, and that was another piece of the cytokine storm process. A lot of things were overactivated, and STAT3 and interleukin-6 and NF-kappa beta are the main teammates. Both hepatitis B and hepatitis C viruses, which induce hepatitis and cause hepatocellular carcinoma, activate STAT3, while HTLV1, Epstein-Barr virus, and papillomavirus activate STAT3 and NF-kappa beta. Okay, so here's the deal. We know that hepatitis B and hepatitis C could lead to liver cancer, especially if somebody was drinking too much, and then you've got a local initiator called alcohol, and then that you could see that as part of an amplification process. The thing that bothers me here with Epstein-Barr virus and papillomavirus is that those are very common, especially Epstein-Barr virus. So we already have, you know, I think it's 90% of us have it. Who knows who sprinkled that one on us? But they add up, and that one can activate STAT3, both STAT3 and NF-kappa beta. And so that's why they say with COVID, if you have Epstein-Barr virus, there's a good chance that, you know, that correlates with long hauler. And then Epstein-Barr has been linked to multiple sclerosis. Almost done. Consistent with the notion that severe COVID-19 is a cytokine storm syndrome, great, it's talking about it. The severity of COVID-19 is associated with an increased level of inflammatory cytokines such as interleukin-6, granulocyte macrophage, colony stimulating factor, and TNF-alpha. The macrophages are a part of this story. Among the elevated inflammatory mediators, and you'll see in diseases, you know, what you really see is the innate immune system, which is the monocytes and macrophages. Sometimes those are kind of like the main players of the immune system. As long as those things are just firing, then you've got this T cell and B cell activity. And if the T cells can't do anything about the problem, you know, my understanding, like if you have like mycotoxins and mold in a biofilm, you can have an overactive and innate immune system that are constantly producing these cytokines, and, you know, but the T cells just can't get and clear up the problem. And then round and round you go, and the person has chronic fatigue syndrome and all these other issues. And of course, interleukin 6 level is highly correlated with COVID patients that needed mechanical ventilation. Since SARS-CoV-2 uses angiotensin converting enzyme ACE2 as a receptor, it is speculated that SARS-CoV-2 induces pro-inflammatory cytokines through, like I said, angiotensin 2, angiotensin type 1 receptor, as SARS-CoV does. And I think that's where the English is weird, but or maybe it does. Maybe SARS-CoV-1 does affect that receptor as well. Bottom line is it's activating NF-kappa beta. Too much NF-kappa beta. The angiotensin 2, angiotensin 1 receptor axis activates the NF-kappa beta pathway through various growth factors, pro-inflammatory cytokines. This axis activates ADAM17. We know that that's a disintegrin, disintegrates the interleukin 6 receptor, allowing it to be soluble, attached to interleukin 6, and then travel and trigger other and continue this amplification process, which generates the mature form of endothelial growth factor ligand. Now that attracts, that actually is where, if you think of migration of, it helps, say the endothelium has that expression, that actually helps with the when the leukocytes demarginate and they're skipping across the endothelial cells, and it can attach to that ligand. And so you've got that infiltration of leukocytes, the immune cells, this immune non-immune cell communication, TNF alpha, 2 NF kappa beta stimulators. So that even the ligand triggers NF kappa beta, and perhaps TNF alpha triggers more NF kappa beta. The angiotensin 2, angiotensin 1 receptor axis activates the NF kappa beta pathway through various growth factors and pro-inflammatory cytokines. This axis activates ADAM17, which generates the mature form of the EGFR ligand and TNF. Okay, I just read that. Sorry about that. Since an activated interleukin 6 amplifier enhances the production of chemokines to recruit lymphoid cells and myeloid cells, including Th17 cells, into the lead. Myeloid cells are just, they come from the bone marrow. They're the immature cells. So you get more immature cells also being attracted, which eventually will mature. The interleukin 6 amplification could further be enhanced. The massive cell death commonly observed in cytokine storm, regardless of the inducer type, activates damage-associated molecular pattern, DAMP. That's what gets recognized by those tongues of the macrophages, tasting and going, oh, something tastes, unfortunately, really good. These events, or it tastes really bad, we got to do something about it. These events further induce pro-inflammatory cytokines, including interleukin 6 through NF kappa beta activation. Consistent with the animal models, it was reported that angiotensin 2, angiotensin type 1 receptor axis inhibitors may be beneficial for COVID-19 patients to decrease serum interleukin 6. And yes, if you look at literature, you look at this now, maybe for me, it looked like it was as early as 2013. They're already talking about using angiotensin receptor blockers like losartan and Cozar to treat autoimmune disease. And of course, Dr. Halas had talked about the literature that's supporting that, that would fit for COVID, that you could buffer a cytokine storm to a certain degree by using losartan. And, it was really strange because I was like, oh gosh, what, we should have done that early, like way at the beginning around, spring of 2020. Well, magically, I'm not sure what it was. I mean, losartan got taken off the market, and so did other ARBs get taken off the market. I mean, it's just so amazing that, you know, cancer, I guess they found that it was increasing you know, it was a bad batch. It was a bad batch. And so thank goodness our amazing protectors made sure that they took it off the market just in time for cytokine storm. Anyways, it's just things that go through my head. Of note, aging, obesity, and then inflammation-related diseases such as diabetes and cardiovascular diseases have been shown to be risk factors for, you know, by the way, you know, I don't know if we can do anything about what's going on. I mean, I really have come to the conclusion it's, you know, I mean, at least we can laugh about it. But I mean, honestly, what are we going to do? You know, I think we're dealing with something far more powerful than just, oh, let's just like we little people can change anything. I mean, I hate to think like that, but anyways, I mean, you know, all we can do is make the best of it, learn, help the people that we can, and, you know, focus on things that matter. Of note, aging, obesity, and inflammation-related diseases such as diabetes and cardiovascular diseases have been shown to be risk factors for severe, of course, see, it makes sense now. Aging, senescent cells, obesity from mechanical stress, releasing cytokines, and inflammation-related disease, diabetes, cardiovascular diseases. And yeah, they were in bad shape. As discussed in this manuscript, these risk factors are all associated with chronic inflammation, which could decrease the threshold of the activation of the interleukin-6 amplification to induce cytokine storm. And you see it's decrease the threshold. Okay, so these things pile up. They pile up, and then you know, then the storm comes. So officially, and you know, I'm going to skip the pictures, because if you don't have a picture in your head by now, I don't think that those pictures that give it justice. You know, they were more confusing to me. And so let's just know that we have it in our head. Interleukin-6 is burned into the front of our brains, and that this is not random stuff and things pop up. There is a definite logic to this whole thing. At the time of its discovery, 1986, interleukin-6 was considered one of many cytokines, you know, just one of many cytokines, you know. It has since been clarified that interleukin-6 is a critical factor in inflammation, autoimmunity, and cancer, and its inhibitors are used as therapeutic agents for severe diseases already, with the potential of being expanded more into the future. So, you know, you can see this article is really more about, we need a drug, we need things that block interleukin-6. You know, when we translate this stuff, okay, as translation medicine doctors, which is what we are, that whether you're anti-aging or open-minded physician, you're reading between the lines and you're saying, okay, of course, it's all leading up to the magic interleukin-6 drug. That's the big answer. Well, we know that we have all these other stressors that we can affect. And, you know, whatever drug they're doing, that's at the point of mechanical ventilation, at least where it is right now. The anti-IL-6 receptor antibodies, tazolizumab and sarilumab, and you're familiar with probably with the tazolizumab. That's what's being used in the hospital, at least from my knowledge base, are used to treat rheumatoid arthritis, Castleman's disease, and CAR-T-induced CRS, chronic respiratory syndrome. Not sure what that means. I apologize. And have promise for treating the severe form of, and I think this is a 2020 article, so this is before it got repurposed. Other inhibitors against interleukin-6 STAT3 signaling pathway are under development. One of the reasons why Okay, anyways, one of the reasons why interleukin-6 is a key cytokine in inflammation is that it has a wide range of target cells because of its trans-signaling mechanism. Interleukins, so it's the transit, it's that trans-signaling mechanism. That's a big piece of the puzzle. Interleukin-6 usually acts on lymphoid and myeloid immune cells expressing both interleukin-6 receptor alpha and GP130, but it acts on a wide range of non-immune cells as well, including fibroblasts and endothelial cells that express GP130 during inflammation. So you can see how all these other myeloid cells can be affected. At the time of it, oh, well, guys, that's it. That's all I got.
Okay, thanks. Thank you very much, Dr. Joseph. Anybody have any questions?
Hope that was illuminating.
A lot to think about. Any questions?
Yeah.
From anybody? Can you give us a 30-second wrap up, sort of a summary?
Yeah.
Is that possible?
Yeah. Yeah. So here's what it is, and I pushed the wrong button, but the point was made, and in the last slide, what it was saying is that, you know, they actually they said, well, we need to test more drugs, and they even mentioned peptides that could, and so that triggers also too, you know, maybe there's a lot of peptides out there. If you look through them and start looking them up, you'd be amazed that you might find one that has a more direct effect on interleukin-6, and you might be able to say, okay, if somebody's in a really, you know, advanced, you know, chronically inflamed state, you know, then we could use that as a big gun. But the main point is the thinking. Okay, so when you think about disease, I would think about interleukin-6 amplification, the fact that Th17 is always, you know, this out of control inflammatory process is always at the forefront. But the other thing is to realize, look, this leads to cancer. Okay, this regulation, this combination of the inflammatory immune system pathway, and F-kappa beta, and the cellular division pathway, differentiation pathway, they're connected. And when those get out of control, they enhance each other, and too much inflammation for too long a time will affect the cellular division and the eventual tumor formation through specific pathways. And they are mostly triggered by the buildup of environmental stressors. And so we have to get serious about getting rid of these stressors. And that's my conclusion.
Okay. All right. Anybody have any comments, questions? Lots of thank yous in the chat, Dr. Joseph. Thank you for being with us again. We always enjoy your insights.
Thank you.
From Brad Stoker, hydroxychloroquine inhibits interleukin-6 and 17, and ivermectin inhibits LPS-induced production of cytokines such as TNF-alpha and interleukin-6. Just saying.
Exactly, and so that's, see, and that also, and of course, I love the saying, you know, so that we're not shooting in the dark. Then we understand why we're using ivermectin and why we're using hydroxychloroquine, you know, why those would help with COVID. And it has to do with reducing or modulating interleukin-6 and Th17, which is being amplified. And then of course, leading to the abrupt cytokine storm, which is the sped up version of, you know, we're in the slow version. COVID was the explosion version. everything at once. Intermittent fasting, good. I'm glad you said it. When I think of interleukin, intermittent fasting, you know, a couple of things goes through my head. Number one, you're detoxifying. You're getting rid of the stressors, and you know, you're shrinking fat cells. You're getting rid of toxins, and basically you're getting rid of stressors. You're getting rid of the mechanical stress from the fat. And it's tough. I mean, you know, look, we're inflamed, we're puffy. It's hard to, it's not our faults that we're overweight. I mean, I'm overweight still. I mean, literally, if technically I am. And so we have further to go. You know, there's a lot more underneath the surface. So intermittent fasting is really the, you know, whichever way you do it, and that's a lecture in and of itself. And I wish we had more concrete programs, medical programs that just do this. But, you know, so far I'm just, you know, I use certain products and, you know, the most I'll do is 48 hours without eating anything. And usually I have some sort of drink that helps with the detoxification processes theoretically. And, you know, that really gets rid of a lot of bad stuff. And that's why people feel so much energy afterwards. It reduces the inflammation. People lose weight, but think about this. Why would they lose so much weight so quickly? Well, it would be because most of their weight was from inflammation. They were puffy and swollen. And that's where the weight came off, because the inflammation went down, the interleukin 6 went down, Th17 and all that stuff, and their cheeks are rosy and they're happy. So yeah. Anything else?
Besides naltrexone, how would you, again, we talked about interleukin 6. Any other suggestions for reducing interleukin 6?
Yeah, so when I think of naltrexone, I think of, well, I think of its effects on the microglia. You know, I think the central nervous system is the biggest thing. I mean, it's really, you know, if you've had COVID and you've had long hauler type symptoms, I mean, you've probably gotten a glimpse of what it's like to feel like you've got neurological disease and being out of balance. It's you get a snapshot of what early multiple sclerosis could look like. And so naltrexone from that standpoint is excellent. But in all honesty, you know, the peptide ARA290, which is erythropoietin peptide, is next level, because not only does it modulate specifically the microglia, because that's what erythropoietin does. It's the part of erythropoietin that modulates the microglia. And imagine that they also modulate the monocytes floating in the bloodstream. But also the same receptor that it attaches to naturally also is the innate repair receptor, which is on damaged cells or damaged neurological tissue. So you've got a peptide that not only modulates the microglia, but also upregulates it. It flips the switch from innate immune response to innate repair using our natural receptors. So yeah, naltrexone makes sense, but it doesn't have the activating the repair side of things. And you know, there's some side effects, you know, as far as nightmares and things like that at night. It's still it's medical. It's better, but if we can have our own, you know, fragments of our own communication system, and if we're into this wildfire and we need some help, we need to upregulate because we're in a vicious cycle, but our bodies can't do it. Well, to be able to put out the fire that way with no side effects, essentially, I mean, it's natural. That to me is the next level. And a lot of these issues, but you have to find out whether it's Th1 dominant or Th2 dominant. I'm just finding that Th1 dominance seems to be more common. And so it's modulating Th1 and Th17. So that's my take on naltrexone. Naltrexone was a huge leap forward because it was the thinking was in the right direction. But I think, and of course we should look at the data and to actually see it, but I'm speculating that making use of ARA 290, and I've used it in all my neurological, I can tell the difference when I'm having the sensation that my neurology is not right, and I've been really messed up since the last 2 years. Long hauler, like I have mold in my heater. I didn't realize my furnace. I didn't realize, and that's been spitting out mycotoxins. I can see how this amplification process, can cause a continued neuroinflammation, overactivated microglia, perhaps attracting those Th17 cells. And next thing you know, I'm fatigued, I'm brain fogged, my memory is down. I mean, I couldn't even talk like this like a year ago. Literally, I had word finding problems. I had balance issues. I had some situations where I'd be in a store in line and I have to grab onto something because I literally felt like my legs were going to give out. And then I would I would inject the ARA 290, just like any other peptide, and the symptoms would go away.
How long do they last? How long is the ARA 290 good for?
Great. It seems to last, you have it like any modulator, the effect seems to go on double the time that you do it. So if you do it one day, you should expect maybe the next day you're fine, depending on how bad you were. But the day after that, you'll find that some of those symptoms might come back. Or if you do it for like a month straight, you should expect to be good for a month or so. I mean, according to the studies, 4 to 6 weeks. So it seems to be you get double the time. For every day that you do it, you get an extra day. And if you do it just for one day here, one day there, expect it to give you about a day of relief. If you do it 3 times a week, you might be able to get away with finding that, if you do it on a Friday, you might have a Saturday and even Sunday, you're okay. But the good news is if you get rid of all the stressors and you continue to do it, because I had a patient with Lyme disease with autonomic dysfunction, really bad. I mean, nothing worked for her. She follows all the superstars and the gurus and detoxing for 20 years, and she still can barely leave her house. She looks super healthy because she's impeccable with her diet, and it's like her whole life is detoxing. She had heavy metal toxicity, Lyme. I don't think she had mold, but they all they seem to have all these things. They accrue. Once the barrier is open, it's like, okay, why do they have heavy metals? They've got Lyme, they got mycotoxins, and then they're an autonomic mess. And I gave her ARA 290, and within 2 weeks, she felt normal for the first time. But here's the real gold, is that we know in regenerative medicine that it takes 6 to 12 months to regenerate anything. So if it's activating innate repair receptors, so you're turning off the immune system, it's yin yang. It's like a light switch. You turn the lights off, you start to repair. Well, is it possible that you repair and heal? Because after about between 5 and 6 months, I spoke to her. This is the hardest patient I've ever had. And she's like, yeah, I'm hardly using it. So that tells me, she uses it when she needs it. So that
Mhm.
tells me she's actually done it consistently long enough that she's actually started to heal chronic, whatever it was, demyelination, and she doesn't need to use it as much. That's promising. That's the,
what, sorry.
go ahead.
I was going to ask you where's your source?
Fortunately, after I realized, woke up to ARA 290, I had to get it from outside the country. But shortly after, it was available at Wells Pharmacy. It was available at Pharmacopeia, but there's a place called Pure Pharmacy in Indiana, and I've tested it. I've used it. They are legit. You get twice the milligrams, say for less. It's slightly less expensive than Wells and Pharmacopeia, but you get double the amount. And because it is expensive, it's one of the more expensive peptides. You know, if you're going to use it every other day, it's got to be affordable. I mean, it could cost $600-800, you know, with the regular price, but Pure Pharmacy, you get 8 milligrams per cc. Or in fact, I think you have to indicate and ask them for 8 milligrams per cc, and they'll do it for the same price.
Okay. That's Pure Pharmacy, you said?
Pure Pharmacy in Indiana. I believe it's outside of Indianapolis. It's legit.
Okay.
And they also have thymosin beta and thymosin alpha.
Really? Okay.
Yeah.
Okay.
I guess they're taking their chances.
I suppose so. Okay. Well,
mean,
that was quite enlightening. Just a couple of comments. So I worked with some autistic kids, and one of the things that we found that there's a disconnect between early on between growth hormone and IGF-1. The growth hormone levels are usually high. The IGF-1 levels, which are the usable portion of growth hormone, are low, and the culprit is interleukin 6. That's the reason. And so we've done things like intranasal insulin. We used the low dose naltrexone. So we asked about what else could be used is anti-interleukin 6. Statins, believe it or not, in low dose, 10 milligrams of torvastatin. Verapamil, 10 to 40 milligrams. There is, and I can never pronounce it. It's one of the biologics. It begins with a T. Which is that's what it is. It's an anti.
Tazolizumab.
Yeah, I can't pronounce it.
I know. They get.
And then a few other things: N-acetylcysteine, quercetin, luteolin, rutin. There's a combination quercetin, luteolin, and rutin called Neuroprotect. You can get that on Amazon. It's about $39 a month. Adequate vitamin D, of course, and zinc. So those are all interleukin 6 disruptors. So
and that's fantastic because, again, we don't want to, just have a one-hit wonder. I think ARA 290 is, I think it's the biggest thing. It's the big aha for me. But, I think we have to think in terms of a concert approach, a symphony approach, and using other things and not just relying on one peptide. But I will say, if you're looking to see, what about autism? What about this? What about that? What about dementia? What you want to do is you want to look up erythropoietin and you'll see that really all the studies, hundreds of studies, are with erythropoietin, and they're with erythropoietin. And if erythropoietin is helping significantly that problem, which you'll find it always does, just know that's the same as ARA 290. The difference between ARA 290 and erythropoietin is that the ARA 290 is the part that hits those receptors. It just doesn't produce red blood cells or stimulate red blood cell production. And even we talked about testosterone last night, and that testosterone increases EPO. It's ARA 290. Yeah, it's a fragment. So it's just the part. It's a little immune sequence, amino acid sequence, a helix, and it's just the part that binds the EPO receptor and innate repair receptor, which is, it's kind of like, it looks like that, sort of like that the two arms fits right in there, and that's the thing that you see over and over, is that all you need is the ligand that hits the receptor, and so you don't need the whole hormone necessarily. You just need the part that hits the receptor, the fragment. So it's not modified, it's not transformed. It's just the receptor, just what it is.
Okay. Okay, anybody else? Any other questions, comments? It's getting late, so we're going to probably thank Dr. Joseph for a fabulous talk. It's very complicated, and makes it breaks it down quite nicely. Dr. Burgess, you got anything here? You're looking
No, no, wonderful talk, important information. So thank you.
Oh, you're welcome. My pleasure.
okay. A couple of
All right,
things.
guys.
We finally got the videos from the March conference. Thank you, Dr. Joseph.
Welcome.
They're not separated. They're by day, and at the beginning, those of you who were there might remember we had some internet glitches. So the first video, at the moment there's no sound. We're working on it. But if you're interested in 26 CME credits, if you weren't there, AOA or AMA, let me know, and we'll be able to get them to you. It has 2 hours of ethics, 2 hours of pain management, and 1 hour of suicide prevention also included, which a lot of the Western states, at least the DOs require for licensing. So all of that's there. It's $5.95, and everything will go to the. I have it set up that it goes through me, but everything will go to the AOSRD. For OMED, our program has been accepted, and we're ready to go. Those of you, Dr. Spear, who are on the program, and Dr. Burgess, we need to have the conflict of interest form signed by June 29th and out to them. So we'll get them to you in the next day, and please just sign it, send it back. And if you don't, then I have to sign it myself. And, I try not to do that. You didn't hear that. So that's, you got anything else to add, Dr. Burgess?
No, we're good.
Okay, Dr. Spear, anything? Dr. Gerber, Brad? Dr. Patel, thank you for being with us. Dr. Joseph again, and Marie, always, our favorite lay fan. Thank you so much. Here's my contact, and that's wrong. So DOCTRBIL9 at gmail.com. Here it is. That's correct. If you're interested in the our conference from March, the end of March, love them or hate them, we have Dr. McCullough there. He gave us a 2-hour talk, and that is actually on our webinar website also. I posted that a couple of weeks ago. And also the webinar that he had with Dr. Halassa just a couple of weeks ago, also with the author on his book. That's on our that's on our AOSRD.org webinars, and you'll see them there. And all of the talks, like probably 90%, I want to say, well, probably 90% of the webinars that we've had, we're coming up on almost 2 years, are there, and they're free. And if you're interested in them, just take a look, and you'll see all sorts of superstars from the anti-aging world, rheumatology world, including Doctors Burgess and Dr. Spear. And we have Felice Gersh, Pam Smith, Kathleen O'Neill Smith, Dr. Halassa, Dr. Joseph. And, you know, you pay lots of money to go to conferences to hear these folks speak, and it's all free. So with that, I'm going to say good night. Next week, Dr. Halassa is going to be talking with us on Hashimoto's thyroiditis. And I'm going to throw in my 2 cents also. I was in on it. I had a couple of things to add, so I'll you know, back them up. Anybody have any questions, comments? You can get me here. You can get Dr. Burgess. Also, if you have anything to do with OMED, and then we're working on our next March conference also. I'm leaning toward Las Vegas again. Only we're getting a pretty good. We're not going to the same place, that's for sure. But we found a really nice place. Dr. Crowley's friend has a hotel that they renovated. It's clean. There's no casinos there. There's a gourmet restaurant in there, and it's actually made for conferences. And the room rates, I don't know in the last 2 months, but the room rates were it was $99 a night. It's about 3 blocks off the strip. It's called the Ahern Hotel. So that's where I'm leaning to, because we're getting a nice deal there, and there's none of this. We had the IT issue. So that's where we're at for now. We'll see you next week. And if anybody needs anything, you know where to get me. I'm gonna sign off. Thank you, everybody.
Thank
And
you.
good
Thank
night.
you.